Welcome to the Fluid in Advanced Manufacturing Group. Today, we will be looking at how to make an alginate gelatin hydrogel, and how we can use a 3D printer to print various patterns using this gel. First, we can use a micropipette to place 5 ml of PBS, which is a water-based salt solution, into a glass bottle. Then, add 200 mg of gelatin to the glass bottle. Give it a stir, and wait a few minutes until the gelatin dissolves. Then, add 50 mg of alginate to the glass bottle. And give it a stir. We can use the thermoprobe to check that the water bath has reached 70 degrees. We use a water bath to help dissolve the alginate. Using a clamp, place the glass bottle inside the bath, then leave for at least 1 hour. Once the alginate has fully dissolved, we can place the mixture inside the syringes, ready to be printed. At the moment, the material is still in liquid form. We can transform the liquid into a firm gel by placing it inside the fridge for 1 hour to let it cool and set. Once the gels have set, we can attach the syringe to the 3D printer. Play around to set the right parameters, including speed and pressure. Here is a video of the gels being printed with a lattice design. We can check the quality of the gels that has been printed by examining it under the microscope. Here, we can see that the gel was not able to print continuously. However, we can move the sample to also analyze areas where a nice lattice has been formed. We can also adjust the magnification and focus the image to see the printed lines much clearer. Thanks to the available 3D printing techniques, hydrogels can be combined with cells to create living tissue. This is known as bioprinting. For example, in 2019, a group of researchers from Tel Aviv University successfully bioprinted the first functional heart, the size of a cherry. Although this is not yet reality, the goal is to eventually develop functional 3D printed organs, ready to be transplanted, to replace damaged or diseased areas. Thank you for joining the FIAM group.